sir.
Good afternoon,
Good
everybody.
afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon. Okay.
Good afternoon, sir.
Good afternoon. So, any doubts or difficulties so far? Any doubts so far on whatever we have been doing?
सर क्वेश्चन नंबर 7 में सर मेरा आंसर आ रहा है 66.1 बट बुक में दिया हुआ 33.1.
Question number
7 sir, exercise 4.
exercise 4, question number 7. Okay, box shaped vessel 18 by 5 by 2 floats in salt water at a draft of 6.1. Correct? Yes, 6.1.
Question number 7, I think. 1.4.
वो 1.4 है.
सर क्वेश्चन नंबर 7 सर.
Yes, sir. Wrong. लिखा है उसमें draft.
वो ड्राफ्ट लिखा गलत है, वो 1.4 है. करेक्ट?
Yes, sir.
1.4 आएगा आपको.
तो आपने 1.4 करके करा है? There's a typo error in some of the books. So basically you will find out the total volume and then you will find out the underwater volume. And दोनों को सब्ट्रैक्ट कर दोगे. तो इसमें कोई टेक्निकल कोई डिफिकल्टी नहीं है इसमें.
वो तो सर वो आ तो गया बट मेरा आ रहा है 66.1 सर. ड्राफ्ट में लिया 6.1.
नहीं, 6.1 नहीं लेना है ना. अगर खुद सोचो, अगर मेरे बॉक्स की हाइट ही 2 मीटर है तो 6.1 तो ड्राफ्ट मेरा 6.1 हो ही नहीं सकता ना. यू हैव टू थिंक इट लाइक दैट. इसलिए तो वो 1.4 कर दो उसको. वो टाइपो एरर है.
ओके, थैंक यू. ऑल कंप्लीट.
ऑल कंप्लीट. बाकी कोई डिफिकल्टी किसी को, किसी क्वेश्चन में? ऑल ओके? ऑल इज फाइन?
यस सर.
Okay, great, wonderful. So we are going now to slightly more technical stuff now, जो कि actually हम ship पे करेंगे use. So I am now going on to some terminologies. I'm going to chapter 5 now. So, chapter 5. And that is, what is the effect of density on draft and displacement? So when I change my densities, क्या फर्क पड़ेगा? Chapter 5. So basically we have to try and understand that when I'm going from sea water to fresh water, okay, I'm going from Chennai. Chennai is in saltwater density, in seawater density, and let us say I'm going to Haldia. Haldia is near Calcutta. It's a freshwater port. So I am going from a higher density to a lower density. So what will happen to my hydrostatic draft? Anybody?
So the draft will increase.
Increase sir.
Draft will increase.
Draft will increase. So my draft will increase. So I will have what is called as a mean sinkage. I will have a mean sinkage. My draft will increase.
सर दिखाई नहीं दे रहा, ब्लड आ रहा है.
What about the others? सबको ब्लड है?
क्लियर है सर. Clear है sir, no blood.
Huh?
Clear है sir.
So what you can do is you can just log out and फिर से log in करो. Just hang up, leave करके
Okay.
and just come back again. So then probably it will become more clearer.
Clear sir.
Okay. So I will have a sinkage. So my hydrostatic draft will increase. So density decreasing, draft will increase. Remember, they are inversely proportional to each other. Vice versa, when I'm going from Haldia to Chennai, density is increasing, draft will decrease. So therefore, the hydrostatic draft will decrease. Now, for the first part of it, supposing at Chennai, my vessel's displacement was 50,000 tons. And I pick up the ship and I put it at Haldia now. What will be my displacement here? At Haldia. Displacement same रहेगा. Does everybody agree to this statement?
Yes.
Yes sir.
Displacement remains constant. Displacement does not change. What changes is the underwater volume and therefore the draft. The displacement remains constant. Okay. The underwater volume will change. Draft will change. Displacement remains constant. Okay. Now, if I am moving from salt water to fresh water, the change in draft, this is called as freshwater allowance. The increase in draft is given by the term freshwater allowance. Similarly, when I go from freshwater to salt water, the decrease in draft is called as freshwater allowance. And this freshwater allowance is given by a formula W upon 40 TPC, where W is the displacement of the vessel, TPC is the tons per centimeter immersion. Let's check the units. W is in tons, TPC is tons per centimeter. Ton cancel, centimeter goes on top. So the units of freshwater allowance, when you use this formula, will be centimeters. So freshwater allowance is this. So
सर एक बार फ्रेश वाटर अलाउंस रिपीट कर देंगे, कुछ नेटवर्क प्रॉब्लम आ गया था.
so जब मैं चेन्नई से हल्दिया जाऊंगा तो जो मेरा ड्राफ्ट जो मैं इंक्रीज होगा वो क्वांटिटी कितनी होगी? दैट क्वांटिटी इज कॉल्ड एज फ्रेश वाटर अलाउंस. एंड फ्रेश वाटर अलाउंस इज नथिंग बट W upon 40 TPC. Checking the units, W is in tons, TPC is tons per centimeter, ton cancels, centimeter goes on top. So the units of freshwater allowance will be centimeters.
All right, sir.
Okay. So this is the basic fundamental of freshwater allowance. Now there is something called as, इसमें TPC आ जाता है. Now TPC जो है that changes with density. TPC changes with density. So therefore, the TPC which will be used for calculating, and the freshwater allowance is also directly proportional to displacement. That means as my displacement keeps increasing, the freshwater allowance will also keep increasing along with the draft, because displacement will be proportional to the draft. Proportional means it'll increase with the draft, not at the same rate. So that means if draft increases, freshwater allowance also increases. So therefore, the freshwater allowance usually given for a ship is at the summer draft. Okay. Now there is something called as a density in between freshwater and saltwater. So supposing I am talking about a density 1010, that will be called as dock water. So dock water is a density in between saltwater and freshwater. So when the vessel goes from Chennai to dock water, then that will be called as dock water allowance. Similarly, reverse. And if the vessel goes from Chennai to Haldia, freshwater, then it is called as freshwater allowance. This is called as freshwater allowance. The methodology will remain the same. That is, when I'm going from higher density to lower density, there will be an increase. And if I'm going from 1010 to 1025, there will be a decrease. The formula for dock water allowance is freshwater allowance into difference of the two densities upon 0.025. Freshwater allowance into difference of the two densities upon 0.025. This will give me dock water allowance. Any doubts so far?
सर
हाँ जी बोलिए.
सर इसमें मतलब ड्राफ्ट चेंज होता कैसे, अगर जैसे हम मेडिटेरियन से ब्लैक सी में जा रहे हैं तो हमारे मतलब जैसे ही हम ब्लैक सी एंटर करेंगे हमारी सिंकेज तभी हो जाएगी.
See, so this does not, ये सडनली चेन्नई से हल्दिया में जा रहा हूँ तो सडनली 25 से 1 नहीं आएगा. It will happen progressively, right? But I am not interested in कि मेरा रोज का ड्राफ्ट चेंज क्या हो रहा है. I am not interested in that. If I have sailed out from Chennai at a draft of, let's say, 9.2 meters, right? And at Haldia, I know I will have an increase of 9.2. This thing, I might arrive at 9.25 meters. Same vessel, I've just put there. So this difference of 5 centimeter has occurred because of what?
Change
in underwater volume.
Change in underwater volume, and basically because of change of density it has happened.
Yes, sir.
So that difference of 5 centimeter is what is called as freshwater allowance or dockwater allowance, depending on what be the case.
Okay.
Because buoyancy is decreasing. This was earlier providing me greater buoyancy, greater upward force at Chennai. But when I arrive at Haldia, density has decreased. So therefore, the buoyancy has decreased. If buoyancy has decreased, the vessel will sink because displacement is the constant. Displacement यहाँ पे भी 50,000 था, वो भी यहाँ पे भी 50,000 है. So underwater volume बढ़ेगी. हाँ जी. Any other doubt?
सर डिस्प्लेसमेंट भी तो अंडरवाटर वॉल्यूम पे डिपेंड करता है, तो वो क्यों नहीं चेंज होगी?
Displacement is equal to volume into density. So यहाँ पे मेरी अंडरवाटर वॉल्यूम क्या थी? यहाँ पे मेरी अंडरवाटर वॉल्यूम जो थी वो बेसिकली क्या है? यहाँ पे थी 50 डिवाइडेड बाय 1.025. ये मेरी अंडरवाटर वॉल्यूम थी.
यस.
वहां पे अब मेरी डिस्प्लेसमेंट को कांस्टेंट अगर रखना है मुझे, तो अंडर वाटर वॉल्यूम मेरी कम होगी ना फ्रेश वाटर में. सो वही डिस्प्लेसमेंट पे, वही 50,000 पे डिवाइडेड बाय 1, तो अंडर वाटर वॉल्यूम जो मेरी है वो ज्यादा होनी चाहिए इससे. यहाँ पे ये कम है मेरी अंडर वाटर वॉल्यूम, इसलिए सिंकेज होगी. So this was what was called as displacement remaining constant. I was keeping my displacement constant. Second is draft remains constant. So if my vessel is floating at 9.20 meter draft in salt water, I want to keep my draft the same 9.20 over here in freshwater also. How will that be possible?
सर अंडरवाटर वॉल्यूम कांस्टेंट.
So now my displacement will keep changing.
Yes sir, weight change sir.
My weight will change. अगर मैं ड्राफ्ट को कांस्टेंट करता हूँ, तो अगर मेरा सॉल्ट वाटर ड्राफ्ट सपोजिंग 7 मीटर पे, मेरी अंडर वाटर वॉल्यूम 14,000 क्यूब्स है, तो सॉल्ट वाटर में उसी ड्राफ्ट पे मेरी कितनी होगी अंडर वाटर वॉल्यूम? Let me share my screen with you now. Let me know when you can see my screen.
Yes, sir, we can see.
You can see my screen? Okay. So basically, what I'm talking now about is, first was displacement was constant. Now I'm doing draft is constant. So supposing a ship floats at the same draft on different occasions in water of RD, different RDs. Displacement each time would be different. So supposing I have underwater volume of a ship at 7-meter draft is 14,000 cubes. So in salt water 7-meter draft, my displacement will be 14,350. Same draft, this time in fresh water, my displacement will be 14,000. Same draft, RD 1.01, displacement will be so much. Same draft, RD 1.02, displacement will be so much. Matlab, draft is constant, displacement is changing. ये समझ में आया?
Yes.
Okay. All right. Now we're coming on to something called as, which you are aware of, load line. Now, okay. Now there are port and starboard load lines. We know that. Okay. Now this is based on the trading pattern for the various ships, and so therefore the exact limits. So supposing your vessel is required is less than 100 meters, then वो winter North Atlantic है. All the lines are 25 mm thick, and ये हमारे shell plating पे marked होती हैं. All right. So therefore, okay, let me show you the starboard side. So this is the starboard side one. The deck line 300 mm. The plimsoll mark, which is in line with the summer, 25 mm thick. The OD is 300 mm dia, and the length of the line is 450 mm. The center of the plimsoll mark to the center line of the starboard side load line, vertical line, distance is 540 mm. Each of the lengths of the tropical fresh and the tropical are 230 mm in length. So it starts with tropical fresh, then you have fresh, then you have tropical, then you have summer, and then you have winter. And below the winter, you have winter North Atlantic, only specific for the length of the vessel and for the region where it is plying. कभी कभी आपको ये डायग्राम एक साइड का या दूसरे पोर्ट साइड का ये वाला कोई भी साइड आपसे पूछा जा सकता है ड्रॉ करने के लिए एग्जाम में. ओके, ये जो लोड लाइंस हैं ये वेदर वाइज हैं. सो द वर्ल्ड हैज बीन डिवाइडेड इनटू समर जोन, ट्रॉपिकल जोन, tropical fresh, winter, and winter North Atlantic. The world has been done this. This is done for the safety of the vessels. So the vessel which is in a particular zone, that load line should not be submerged. That means if I am in a summer zone, my summer zone should not be submerged. Similarly, if I'm sailing out in a tropical zone, then the tropical zone load line should not be submerged. At any point of time, no load line should be submerged. That is the important thing. Okay. Okay. The top of the line indicates where the top of the freeboard deck would meet the outer side of the shell plating. Directly below the deck line is the plimsoll mark, or also called as the load line disc. The vertical distance between them is called as the statutory summer freeboard. So the distance, what is summer freeboard? The distance from the deck line to the summer mark is called as the summer freeboard. So the summer draft plus the summer freeboard will give me the total height from keel to the deck line. I repeat, summer freeboard plus the summer draft will give me distance, the total depth from keel to deck line. यहाँ तक clear है?
Yes, sir.
Okay. The upper edge of the line, which is marked S, is with the horizontal line of the load line disc, also the plimsoll mark. In summer zone, the ship can load up to this line in salt water. Vertical distance between the upper edges of the summer and tropical, and between summer and winter, is 1/48th of the summer draft. The dates and limits of the winter, summer and tropical zones are given in the load line rules. So load line rules में winter कहाँ होता है, summer कहाँ होता है, tropical कहाँ होता है, वो दिया होता है. The winter North Atlantic, if applicable, is situated 50 mm below the W mark, measured between their upper edges. The vertical distance between the upper edge of the lines marked S and F and between T and TF is also called as the freshwater allowance. ये clear है? Between summer and freshwater and between
145 का सर, ये 148 1/48 ये क्या है सर? ये
this is the distance, the vertical distance between S and T. So ये distance between S and T, top to top, ये distance जो है ये 1/48th of the summer draft है. Similarly, the distance between ये वाला between T and that is also the same one. The vertical distance between the summer and the tropical and between the summer and the winter is 1/48th of the summer draft.
Yes.
ठीक है? Is that okay?
Yes.
Okay. So let us see example 1. A ship's load displacement is 16,000 tons and TPC is 20. If she is in dock water of RD 1.010, find by how much she may immerse her load line so that she will not be overloaded when she goes out to sea. Goes out to sea मतलब 1.025. वो overload नहीं होना चाहिए. Our load displacement is 16,000, TPC is 20. So freshwater allowance basically is W upon 40 TPC. W is 16,000 tons. TPC is 20. So that means freshwater allowance is 20 centimeters. Dock water allowance is freshwater allowance into difference of the densities, 1025 minus 1010 upon 0.025. That means 12 centimeter. इसका मतलब I can immerse my load line by 12 centimeter at departure, so that मैं जब वहां पहुंचूंगा so that जब मैं I go out to sea, I will not be overloaded. क्योंकि मैं अभी 1010 में हूं, तो मैं जितना डॉक वाटर अलाउंस का अलाउंस है उतना मैं लोड कर सकता हूं. ये समझ में आया कि नहीं? Want me to repeat it?
Yes, sir.
Want me to repeat it?
Yes, sir.
Okay. Let me just unshare my screen first. Okay, can you see my board?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right. So मेरे जहाज की डिस्प्लेसमेंट जो है वो 16,000 टन है. मेरे जहाज की टीपीसी 20 है. ये इस वक्त डॉक वाटर डेंसिटी 1010 में है जहाज. Now she is going from here to 1025. ठीक है? So when she goes from 1010 to 1025, what will happen to her draft? हाँ जी.
Sir, it will decrease.
It will decrease. So my draft will decrease. Correct? That means I should be able to load something more. Yes or no? I should be able to load something more. I can't hear you.
सर उस वाले पोर्ट पे तो उतना अवेलेबल नहीं रहेगा.
हाँ, उस वाले पोर्ट मतलब अगर मैं यहाँ पे लोड कर रहा हूँ इस वाले पोर्ट में और मैं वहां पे जाऊंगा, राइट? तो जब मैं यहाँ से इधर जाऊंगा तो my mean draft is going to increase by how much? That I have to find out.
0.0.
That is called as dock water allowance. So fresh water allowance पहले मैं निकालता हूँ. That is W upon 40 TPC. So this is my load displacement. This will give me my freshwater allowance. That is equal to 20 centimeter. Put it in the formula for dock water allowance. freshwater allowance into difference of the two densities over 0.025. Basically, freshwater allowance का proportion है. That is what it is. $20. 1.025. 1.025 minus 10 upon 0.025. So, इसका क्या मतलब है? इसका मतलब ये है कि the ship can immerse her salt water load line by 12 centimeter ना? Yes or no? That means मैं जब यहाँ पे सेल करेगी let me show it to you. Let me know when you can see my.
Yes, sir.
All right. So basically, this ship can immerse her summer यहाँ पे ला सकता है by 12 सेंटीमीटर. समझ में आया कि नहीं?
Yes.
Because dock water allowance is, see, summer is here, tropical is here, fresh is here. Your dock water density is somewhere in between fresh water and between salt water. यहाँ पे है ना, somewhere in between, बीच में.
Yes, sir.
तो ये 12 सेंटीमीटर है. 12 सेंटीमीटर का इमर्शन कर सकता है, ताकि जब ये शिप वहां पहुंचेगा सॉल्ट वाटर में तो समर होगा, समर पे आ जाएगा. दिस विल बी द शिफ्ट. Draft has to decrease, right? Draft has to decrease. So अभी जब मैं सेल आउट कर रहा हूँ 1010 पे, तो ये मेरा इस वक्त है 1010 पे.
Yes, sir.
और
समर पे आ जाएगा सर.
और जब ये पहुंचेगा चेन्नई में तो ये समर पे आ चुका होगा, 12 सेंटीमीटर नीचे आ चुका होगा. क्यों? बिकॉज ऑफ द डेंसिटी. समझ में आया?
Yes, sir.
That is the meaning of this. ये समझ में आया? Example 1.
Yes, sir.
Okay. Now we are coming on to example 2. Let me just unshare my screen first so that you can see my board. So, coming on to example 2. Vessel of freshwater allowance 200 mm. So freshwater allowance 200 mm goes from 1018 to 1006. 1018 to 1006. Find the change in draft and state whether it will sink or rise. So, सबसे पहले, the density is decreasing, so draft will
Increase.
Okay, so there will be an increase. So we are all agreeing to this, that the draft will increase. Now, how much will it increase? That's the question. So, dock water allowance is freshwater allowance 20 mm into difference of the two densities. That is 1018 minus 1006.
So freshwater allowance 200 and
Oh, sorry, my mistake. Freshwater allowance is 200 mm. And she's going from 1018 to 1006 or 1016, I don't know. 1006 over shayad.
6.
6. So 1018 minus 1006, that is 0.012 divided by 0.025. It's a ratio of the 200 basically. So that will come as 96 mm. That is 9.6 centimeters. So therefore, the vessel will sink because it will increase by 9.6 centimeters. So if I'm sailing out from 1018, I need to take care of this amount so that when I arrive at 1006, I will be at my whatever draft that I want. So supposing this is my summer draft, over here I'll be summer minus 9.6. Do you copy? Do you copy?
Yes, sir.
Okay. So basically my dock water allowance is 9.6 centimeters. I will increase by that much. I will sink by that much. Example 3. Box shaped vessel 24 by 5 by 3. 24 by 5 by 3. This is a box shaped vessel. She has got an even keel draft of 1.2 meters. Draft, even keel, 1.2 meters. And this is in dock water, density 1009. In 1009. I have to calculate the draft in dock water 1019. So from 9 she is going to 19. So firstly, I will calculate displacement in 1009. 1009 displacement will be volume, underwater volume 24 into 5 into 1.2 into 1009. This is my displacement in 1009. And I have to find out my displacement in 1019 and I have to calculate the draft. my displacement will remain the same. So 24 into 5 into draft in 2019. 24 5 24 5. The draft will be 1.2 in 2009 upon 1019. So draft will be 1.188 meters when I go, because I'm going from less density to more density, my draft will decrease. This will be my new draft. Is this okay with everybody?
Yes, sir.
All right.
सर जो पहले वाला एग्जांपल आपने करवाया था
हाँ जी बोलिए।
डॉक वाटर अलाउंस तो अपन ने निकाल लिया, बट लोड
डॉक वाटर
पोर्ट
अलाउंस
में
डॉक वाटर अलाउंस निकाल लिया।
बट लोड पोर्ट में अपन उतना ज्यादा लोड थोड़ा कर सकते हैं समर लोड लाइन के ऊपर,
तो कम करेंगे ना। तो मैं इतना ड्राफ्ट में कम करूंगा लोड पोर्ट पे, ताकि मैं आई हैव टू कॉम्पेंसेट फॉर दिस। मेरा जहाज जो है एट सी सिंक करेगा।
नहीं सर, इसमें तो अपना ड्राफ्ट वो होना है ना, लेकिन पोर्ट पे कम होना है।
करेक्ट।
फॉर एग्जांपल नंबर 1 पे तो अगर कम होएगा तो अपन उतना ज्यादा लोड थोड़ा कर सकते हैं लोड पोर्ट, तो इसमें तो अपने को लोड पोर्ट के हिसाब से देखना पड़ेगा।
करेक्ट, बट अगर सपोजिंग मुझे डिस्चार्ज पोर्ट पे फाइनल डेस्टिनेशन पे मुझे किसी समर पे आना है, दैट मीन्स वो मैक्सिमम पे मैं वहां पे पहुंचना चाहिए, तो यहाँ पे कितना सेल कर दूंगा मैं? क्या सेल करूंगा?
तो समर पे आना है तो फिर बट स्टिल सर लोड पोर्ट पे समर ड्राफ्ट से ऊपर थोड़ा लोड कर लेंगे।
करेक्ट, दैट्स राइट, दैट्स व्हाट आई एम ट्राइंग टू से। समझ में आया?
यस।
तो सी डिपेंड करता है ना कि कहाँ पे मेरी रिस्ट्रिक्शन है। यहाँ पे रिस्ट्रिक्शन है या वहाँ पे? जनरली तो वहाँ पे होती है ना डिस्चार्जिंग पोर्ट पे रिस्ट्रिक्शन, जनरली तो वहीं पे होती है।
यस सर, तो हमारे में हो जाती थी तो
मेरे को यहाँ, तो मुझे यहाँ से कमती में जाना पड़ेगा ना, बिकॉज मैं सिंक करूंगा।
यस सर,
तो मुझे 9.6 सेंटीमीटर सिंकेज होने वाली है, उसको कॉम्पेंसेट करना है। पहले से ही कॉम्पेंसेट करूं के जाऊंगा। करेक्ट? इज एवरीबडी विद मी व्हाटएवर आई हैव जस्ट स्पोकन?
Yes, sir.
Okay, so simple language में just repeating once again, whenever we go from higher density Chennai to Haldia lower density, my vessel will sink, my draft will increase, my displacement will remain constant. Please remember, my underwater volume is increasing and therefore my draft is increasing. Displacement is constant. Clear है ये fundamental?
यस सर।
ओके, ये सबसे ज़्यादा इम्पोर्टेंट चीज़ है, ये बार बार मैं रिपीट करने वाला हूँ, क्योंकि जब हम जाएंगे हिंडशिप के अंदर एंड उसको करेंगे तो उस वक्त हमारे को ये चीज़ बहुत काम आएगी। सो आई वॉन्ट यू टू डू एक्सरसाइज 5, क्वेश्चन नंबर 1 to 5.
Okay, sir.
एक्सरसाइज 5, क्वेश्चन नंबर 1 to 5. ठीक है?
Yes, sir.
ये चैप्टर जो है ये बहुत इम्पोर्टेंट चैप्टर है, क्योंकि यहाँ पे हमारे बेसिक्स बनेंगे जो कि हमारे को आगे लेके जाएंगे जब हम हिंडशिप में घुसेंगे। सो अगर हमारे बेसिक्स क्लियर होंगे तभी हम वहाँ पे स्मूथ ट्रांजिशन हो पाएगा हमारा. सो इसलिए प्लीज डू एवरी क्वेश्चन ऑफ दिस एक्सरसाइज केयरफुली. कोई मिस्टेक होती है, गो बैक, लुक इनटू इट, जस्ट सी कि मिस्टेक क्यों हो रही है. Try to do the question all over again. That's how you'll have to practice this. Okay?
Okay, sir.
All right. Chalo. Okay. See you then. Bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.